Hello, everyone, and welcome to our 18th edition of our Developers Office Hours with the Scalus Deep Dive session. I'm excited to have you here today. Today's agenda includes an introduction, Scalus vision and roadmap, and a smart contract development with Scala 3. Then after that, we're going to jump into a demo with the payment splitter. That's one of our 20 first common blockchain use cases examples that soon will be available in our GitHub repository. The link is there on the chat. So we are very honored today to have our esteemed guests, Alex and Alexi from Lunter, who will be sharing their insights and expertise through this session. So please note that the first part of the session is going to be recorded as usual, and then you have the Q&A segment after that that's going to be live. So feel free to ask your questions. So let's deep dive and explore how Scalus is revolutionizing smart contracts development in Cardano. Lunter team, the floor is yours.
Yeah. Thank you very much for having us. We'll start with a short introduction. So Lunter is a blockchain R&D lab dedicated to advancing Cardano infrastructure and building mission-critical decentralized products and solutions. We are focusing right now on creating and improving the development experience with the Scalus development platform, and preparing and building the Scala-based node and infrastructure, but also we're specializing in layer 2 protocols, and we're working closely with Hydra Variant and Cosmos. Myself is Alexei Kadakovsky. I'm co-founder and Lunter, and with me is Alex Nemish, who is a founder and CTO. I will speak quickly about the vision of the Scalus, and I think some of you already heard about Scalus, but I wanted to reiterate on this because I think it's important to see the future of the solution and platform. We, as I think other builders on Cardano and also Web2 developers who are entering the blockchain, experiencing this kind of lack of unification in terms of tools, languages, frameworks, and we believe that it shouldn't be that hard to start building with Cardano. That was actually the reason why we started building Scalus. So Scalus by itself is a decentralized app development platform, meaning that we are aiming to cover full stack app development, going from on-chain, off-chain code, but also combining it with the application layers. But also we want to support and cover the end-to-end development flow. So simplifying the setup, supporting development, enriching testing, helping with debug, but also integration and development. And all of this is supported by industry-grade tool set, and that brings the great development experience. It's our vision, and we are working towards it. We are focusing on professionals and businesses who actually want to enter Cardano ecosystem and get things done, simply said. Key benefits, there are plenty of benefits of the solution, but when we're speaking about Scalus, we're actually focusing on three major things. First of them is a productivity boost that we gain with the Scala 3 modern language, like functional language. I think Alex can speak about it a bit later and show it off. But what we have noticed is that when you are working on some products or applications or protocols, when you are having 10 to maybe 15 or 20 developers working for 6, 12, 15 months, you are experiencing this increase in productivity while using Scala and like JVM ecosystem. We also through our previous experience, professional experience, noticed that it also helps reduce the time to market, because you can start prototyping very fast with Scala, but you don't need to throw away this code. You can continue building the solution and actually go into production, and that drastically improves the time to market. But also, we tap into the deep pool of Scala, Java, Kotlin talents on the market, and especially when we're speaking about the Cardano as a financial system of the future, we believe that companies who today find themselves in traditional finance system, having those fleets of Java, Scala engineers, it would be rather important to bridge the Web2 world into Cardano and blockchain development, and that was the reason why we started Scala's platform and why we believe in it. So I already spoke about it, but I really want to highlight that Scalus is not only the smart contracts language, even though today we will be focusing in our demonstration, we will show off how we build smart contracts with Scalus, but it's more than that. It extends, so first of all, it gives you opportunities like advanced optimizations, UPLC builder, like advanced control path and stuff. So you can really extend your smart contracts experience, but also it complements it with a rich library of chain tools, starting from transaction builder, which is in development right now, but we have as well cost evaluation functions. And what's important here is that we, from the same code base, we're exporting it into different platforms. We can have it on JVM runtime. We can export it to JavaScript, to TypeScript, but also to native through LLVM integration. And all of this in the same project with your Scala application. So you don't really need to jungle between different projects to build your smart contract and build your front-end application, then build your server or client or protocol. All of this you can find in the same project, and it's what Scalus actually enables. On the other side, we want to support complete development flow, starting from quickly setting up development environment, bootstrapping your decentralized application from the selection of templates, explore your DApp in one project, as I just explained. Work, enjoy the fantastic development experience, write high quality code, test, integrate, and then debug your solution on the test net and deploy to mainnet. I'd like to give you a quick insight into what is inside of our roadmap. So as of today, and with the help of and support from Catalyst, we have delivered capability of writing smart contracts with Scala 3. We are able to compile them to UPLC with Bluetooth 123 support. We have already script evaluation, cost calculation functions available as a libraries on different platforms. And we showcased the end-to-end development cycle with the integration of YASI tools. And we already have a basic documentation and starter kit. So the development of this is already finished, and we decided in the beginning of the year to start the early adoption. And we were debating between entering like the broader scene or focusing on the smaller group of early adopters, and we decided to go with one R&D lab and two businesses. So we showcased our solution, and we, with the help of our methodology, which helps us to iterate very fast in 1-2 weeks iterations, and with help of our early adopters who are helping us with their feedback, we learned valuable insights from the early adopters. So that helps us to fine-tune the syntax and standard library, and then get an insight in the kind of needs of the developers who are using our platform. I will give you like a couple of examples of the feedback that we already received. So one of them was that it's relatively technical to start writing with Scalus on Scala 3. So we already took this into consideration, and I think Alex will show some insights and some improvements that we have done. But also we have this constant return feedback coming back to us, saying that the documentation should be a bit more clear, and people are really needing the onboarding tutorials. So this is something that we're working on right now. I want to quickly tell you that we have the early adoption club running. So I leave the link here, and with Darlisa will share it in follow-up to this to the demonstration. Basically, we are looking for engineers who want to start building with Scalus, whom we can support in their mission. But also we are looking for engineers who really want to be a part of our club, who will work closely with us to have some kind of development sessions with us, so we can see what type of frictions engineers are having. So basically working with us on iterative basis and to help us improve our platform. So I'll leave the link in the follow-up. A quick insight into the future of Scalus. In the second part of the day, and I hope with support of the Intersect Technical Committee, we want to deliver this capabilities and features. So in the area of onboarding, we're working right now on the new version of documentation. We're planning to release the first iteration of it for the Builder Fest. So some onboarding tutorials and templates, but also we're working on the catalog of standard or common smart contracts and design patterns. I'm sorry. We'll continue polishing the syntax of the smart contracts, and we want to improve our standard library and testing libraries. Then once the basic functionalities is delivered, we want to really dig into advanced capabilities, like bringing the advanced optimizations, type UPLC, expression builder on pair of Plutarch, if you are familiar with it, but also improved pattern matching and macros. On the off-chain library, one of the things that we want to bring is ledger rules and domain objects into our library, simplifying the integration and testing with the Scalus. And we also want to integrate with the Yassi DevTool to actually simplify the day-to-day experience with having a local Cardano network available, but also enriching it with test data packages and adding the toolkit for deployment of smart contracts. This and more. Support us in our work, and hopefully we can bring it to you by the end of the year. It's an ambitious plan, but our methodology and I hope your support will help us to do that. That's it. I'm giving the mic to Alex, who will guide you through the development experience and showcase some smart contracts.
Yes, thank you, Alexei. Let me share my screen. Okay, now let's go to technical stuff. And I'm gonna show you some things that Alexei was talking about in code. So yeah, we let me show you the probably the simplest contract that you can write in Scala today. So once again, Scalus is essentially a way to compile Scala 3 to UPLC. It's like a Plutus. So Plinth currently tries to do it with Haskell. We do it with Scala. Yeah, so this is a Hello Cardano project. We took a similar approach to what's Aiken currently doing. So we expose a set of functions that are specific to a script purpose. Yeah, thank you. Script purpose. Yeah. So let me show you how this looks. If you're not familiar with IntelliJ IDEA, so that's the integrated development environment from company IntelliJ that is well integrated with Java and has very good integration with Scala. So I will try to show off you some of the features like code navigation. So we have this base class called validator that defines a validator for our smart contract. We have an annotation says compile. It means that this code needs to be compiled to UPLC. So this is very generic validator that just calls the particular functions given the script info, script purpose. So we have our spend function, and just wanted to briefly show you what the IDE can do. It has like this refactor module, and you can see that it can do a lot of things. So we can do simple renames, and validator. I don't know if it's gonna immediately show it, change it everywhere, and we can find usages of this function. And navigate to it very simply. So what's happening here in the Hello Cardano? Here we can see that we do this destruction. We receive data as an option of data, and we extract it. We assume that it should be that the data should exist. Otherwise, it's gonna produce an error. Similarly, what Aiken is doing, we're doing this in Scala as well. Here we convert these untyped data to public key hash. So we expect an owner here. Here we expect that this transaction is signed by this owner. And you can see that unlike Aiken or unlike Plutus, we have this usual Java Scala based access to fields via dot. So you can write tx dot, and it's gonna show you all the available fields. So it can give you the hints. And as it's a Scala, it's the usual Scala language. It's not a new custom language. This means that all the LLMs, all the chat GPTs, Claude, etc., they were trained on millions or even billions lines of Scala code. So the code completion by Copilot, for example, is excellent. Here we took an approach of doing the sort of a defensive programming and just doing this require. So we check that we have signed the transaction and we require it to be signed. Otherwise, we throw an error. And in Scalus, you can configure it to to produce traces before it evaluates to error. So you can always see the log messages of the traces of the errors. Or you can disable it. It's just a flag. You can do either way. This was suggested by one of our early adopters, George. I think he's on the call. Okay, so here we essentially convert redeemer to string, and we check that it's hello Cardano, and similarly we require it to be true. That's very simple, very simple script, and we have a test for it. So it's a usual Scala test. We use library called Scala test, and we can run it. It's going to compile and run it. So the magic happens actually. Magic happens here, where we say that we need to compile our validator, and it's going to compile it to our Scala's intermediate representation. And then we can compile it to UPLC and run with our script context. So here we can, IntelliJ IDEA have this X-ray mode. If you double press the command, it's going to show all the types, all the names of parameters, all the implicit arguments, etc. So yeah, after compilation and on running the script, we get this result thing, which we then can assert via usual function. We can assert it's true, and we can get a budget in this result. So in the result, we get either failure or success. We get budget, logs, and costs for all the built-in functions and etc. I've heard something. It's a hand or what happened? Heard a sound? No?
It was just a comment.
Somebody wrote a message, yeah, but we'll read the messages later.
Okay. Anyways, so here, so A can show you the execution of functions, but frankly, I don't find it very useful. We need to check that the execution of our validators are within certain budget, and you can use it. You can check it as a usual assert in your tests. I'll show you the result, the print length of result in a payment splitter. Something weird. Anyways, so this is a basic, simple contract. Let me show you something more complicated. The payment.
Maybe one thing to mention is that one of the feedbacks that we received that it's quite difficult to enter into smart contract development, that it would be too technical to write. So we decided just to showcase that we can reveal part of the domain knowledge onto the surface and actually hide part of the technical complexity of that may be perceived as complex under the hood by just making two helpers. So this is what we're showcasing, and I think through feedback of our early adopters, we can learn what type of business domain knowledge should be on top and what should be hidden, and through iterating on our standard library, we can achieve this easily. Just need your feedback, guys and girls.
Yeah, absolutely. I just recall that I wanted to show you a couple of things that are embedded or already exist in Scala. So, for example, a formatter, like Scala formatter, it just works. There is a Scala FMT tool. You can just, it has a lot of parameters. I just simply let's show me that we can change the indentation level, for example. And just reformat, and it's gonna do it automagically. So these tools are the test coverage tools, formatters, linters, those just exist and work. And obviously, IntelliJ IDEA is not the only IDE that supports Scala. Also, there is a plugin for Visual Studio, and for Vim, Emacs, whatever is your preference, it works. Funny enough, the Metals, the plugin that integrates into Visual Studio Code, they announced recently that they're going to integrate with, implement the MCP protocol to provide the typed contexts for LLMs to generate better code, which is, I think, a step in the right direction. And it's a quite cool development. Yeah, let me show you Payment Splitter. So when we contacted Cardano Foundation, they suggested us to implement the Payment Splitter validator to see how it would look in Scalus, and they have this implemented in Aiken already. So we took a look and just recently implemented the Payment Splitter. So the idea is to have a contract where you can put some money, just a shared project donation address, for example, and these money put into this contract must be equally split between the set of parties or PEs. So they pay. So someone creates this payment splitter script, puts money into it, and then one of the participants can create a transaction that must pay equally to all of the payees, and it should account for the change of the payment initiator. It must be equally divided to ensure the transaction is successful. Just show off that this documentation is compiled to Scala docs, and it's going to be shown as a documentation of this object, and it supports Markdown. So you can do the links. So links work. So they go to the mesh site with the description of this contract. Okay. So again, we say it must be compiled to UPLC. We expect it to be a spending script. It's a parameterized validator. So we, as a first argument, we receive the list of payees that must be paid out to. We've implemented in a way so it's compatible with the Aiken implementation. So the Cardano client leap functionality should just work with our contract as well. And here we go. So we check inputs. We find the PE who is triggering the payouts. We just do a fold left over inputs, and we're trying to find the input that has a credential that is one of the PEs. So PEs contain this credential, and then we find it. If we have already found it, so we limit the PEs to only one. So if there is two inputs with PEs, we fail, saying that we already found the fee payer, because it's then it's a potential issue of multiple PEs getting fee pay. They will pay fees. It's a potential error. So we mitigate it. So if we didn't find it, we just fail. So as a result, we get the option of the payee, and we get it or fail saying that one of the payees must have an input to trigger the payout. Then we go through the outputs, and here we find the split value. Split value is the value that each output must receive. But if it's our payee, then we need to account for the change. So payee has its input, and he pays the fees for the transaction. So, and he must receive, or he or she must receive change. So here we account for change. It's very similar code exists in Aiken implementation. So we just get value, it's inputs minus transaction fees. And the output must be that minus change. Otherwise, we just take an output, and that's the split value. And we compare it to a previous value, previously seen value. And thus, we check that every output has the same value with the count of the change value. Then we check, so we go through the output list along with the payees list, and we check. So if there are more outputs than payees here, we fail, saying that there are more outputs than payees. Thus we strict the amount of payees to the amount of payees. If the and here we check that the output belongs to a payee. So yeah, so there's no other no other credentials in outputs, and as a result, we get a list of unpaid payees, which we require to be empty. And this way, we ensure that all payees are being paid, only payees are being paid, and the change is of the originator is accounted for. And this implementation goes through the outputs only once. So it does not do a multiple traversal of the outputs. Yeah, so that's the implementation. We've looked at how the Aiken implementation does it, and from the requirements, we started to create a set of tests that should cover this functionality. Let me show you the tests. So we've created a bunch of test cases for this validator. And
do you want me to speak about the methodology? Because I think you have noticed that we made a jump from very simple contract to quite a contract. Yeah, a bit more complex. And it's quite difficult to actually write this type of contract without having any methodology. So at Lanter, we're using test-driven development and acceptance test-driven development. So we started with the requirements, and we tried to illustrate it with positive scenarios. So Alex is showing us 3 positive scenarios, which we created through understanding the requirements. So first one is about having one PE and splitting for one PE. So it works for one person. Then we illustrated it for 2 person who are having this kind of gift box. It should work for 2 person. And then we illustrated it for 3 person. So we calculated like how much it should be. I will show you the table after the demonstration. So we made it in Excel. And we're using
show it right now. Show it right now.
Yeah, maybe I should show it directly. So we're using the acceptance test-driven development. So we wrote 3 positive scenarios illustrating that one, so contract having one P. Yes, Derlis?
Yeah, so can you increase it a little bit the font?
Yeah, sure.
Thank you.
So we wrote a table representation of the scenarios. So having one PE, how much money was collected, who is triggering the payout, what is his input, his output, what is the fee, what is the result. So we illustrated it with 3 positive cases. Then we implemented the smart contract as Alex has explained. So our tests were passing through it. After that, we created a set of negative tests. So like testing for absence of inputs, incorrect outputs, missing PEs. For example, at the contract, we had 2 persons that should receiving payout, and the person who is triggering only mentioned 1. Or the situation where we have 2 person for payout, but the person who's triggering mentioned 3rd one, which was not initially initiated. That's how we added the negative paths into the contract. So Alex showed us the negative like error messages and stuff. So those tests allowed us to reveal those controls that we should integrate. And once that was done, we were having this meeting in our team, and we tried to imagine a couple of the edge cases. And one of the edge cases, and I think Alex will show you a bit later, I'll just give you an insight about it, is the situation where you have a remainder from the split. So imagining we have 31 in the box, and we need to split it equally between three P's. It will produce 1 as a leftover, and actually it was not playing very well with our contract. So by applying the test-driven development, acceptance test-driven development, we actually noticed that our smart contract was not performing was not covering this case. It was actually creating a dust on the blockchain.
Essentially impossible to construct a transaction that spans such a case, such an input.
I'll let Alex to showcase this as well.
So in case we have 3 parties, the amount to be split is 31, and if fee is 2, so we expect that, imagine A triggers a transaction, it pays 3 lovelies. So ideally, everyone should get 10. So B and C should get 10, and A should get A should get 10 plus minus change, and change would be C gives 3 and pays fee of 2, so 1. So
basically, it's revealed the business rule that in case when we cannot equally split the box, cannot pay out, the remainder should be used to pay fee. So through this exploration of edge cases, we actually enriched our functional requirements, saying that in case if the split is not equal, then this remainder would be happening would be used as a fee. So the person who triggered the payout, it will cost him a bit less to actually trigger the payout.
Yeah,
so this is an illustration of acceptance test-driven development in development.
Yeah, and basically it's impossible to using this logic to split it equally. So as we can see, that we got an error split unequally, and it can be challenging to debug such cases. So the cool thing about Scalus that we are able to sustain the semantics of the code that runs on JVM, on JavaScript, and as a UPLC compiled code. So you can actually run these functions, run these validators as a Java functions, as Scala functions, and you can debug those. So here, if we see the running code, so we have this our script. So that's our script that we give the payees converted to data, and then we apply the script context to this program, and then we evaluate the program. But instead, we could just directly call this validator as a function, and if we set a breakpoint here, we can just run it as inside the debugger. And we can get inside this change evaluation. We can see that we've got a change of 1, right? Because we found a payee with a value of 3 here, and transaction fee is 2 as in our scenario, and the change is 1, and the expected output is 12. So the split will be evaluated to 11, and previous value is none right now. So if we check another output, we'll see that for expected split is actually 10, right? So it's not the same as the previous value. So that's why this actually fails.
This implementation is not right to this case.
So essentially, I wanted to showcase you the debugger and its capabilities, and you can use it for your project development. And I think there is nothing in Cardano that is remotely close to this, and probably even the whole blockchain industry. I'm not aware of any debugger working with the smart contract languages. Yeah, that's essentially how we find this issue. I didn't have enough time to actually fix it, but it should be relatively straightforward. Another interesting thing is that tests of smart contracts are often, so in Aiken, for example, you can test transactions, right? You can generate transactions and test against these contexts. But those transactions are not checked by the ledger rules. So you can actually can construct a transaction that is not valid by Cardano ledger rules. So one of our goals of the near future is to implement our domain objects for our transaction builder and be able to construct transactions from which we can get a script context, which is going to be correct, which is going to be the one that passes the Cardano ledger rules. So the tests will be not just unit tests, but rather like a functional tests, because you can test like against a real node, which
like
is
you're doing a real application, like decentralized application testing, and in this case, it becomes, at least from our opinion, much more natural to develop a usual development cycle where you first discover the requirements, then you illustrate it with examples, then you decompose it into components, and then you like cover all of this with tests. Today, where we have a feeling that this capability is actually missing in the ecosystem, where you need to test every unit separately. So you're testing validators separately, knowing in head that, yeah, there are some ledger rules that will be protecting us against certain cases. Then you need to test off-chain components, believing that those rules will be controlled. So in Scalus, we want to tackle this problem by providing you a full platform where you can apply all the levels of testing as per normal product or program development.
Yeah, and one more thing, I just wanted to very briefly show you our Scala starter. It's a quick start project that already contains everything set up, and it shows the like full application. It has a main function that is a CLI, so you can run it as a CLI function. It has a backend. It has a server that actually creates the HTTP API, REST APIs server that has a mint endpoint, so you can mint and burn tokens. So it runs a HTTP server that has a Swagger UI documentation. And it has a transaction builder logic. So we use Satya's Cardano client Leap. I think Cardano Foundation is familiar with the tool. I believe Satya is on the call as well. And with this Cardano client library, we use our Scala transaction evaluator to evaluate script execution budget of the minting policy. So Scala implements Bluetooth VM, including all the cost calculation, budget calculation stuff. You can use this natively on JVM or JavaScript. So we build transactions and mint and burn tokens, and we even have a integration test that builds these transactions and connects to a local Yassi dev kit. So we have actually a Yassi node running here, so we can run this integration test, and it's gonna produce transactions and mint and burn tokens. And we can see in a local node, it's in a local environment, it's gonna produce transactions that mint and burn tokens. Where are those? Yeah, here are these transactions.
Yeah.
So you can do the full dev cycle from within a single project in a single language, right? In your backend and smart contracts and tests and calculating budgets, and even you can export your some of the common code as a JavaScript library and potentially use it in your React application. Or if you're adventurous, you can use tools like Laminar and fool your front end in Scala as well.
Yeah. Well, this is a showcase of. Thank you, Alex. It's a showcase of the capabilities that were already available, and like later this year, we're planning to expand on those. So support our project. I put the link to our early adoption club.
Please join, and your feedback will be very important and will be implemented with very high probability.
Yeah, write us some kind of encouragement, but also you can put the wish list. We have a box for your wishes, so put your wishes and we will contact you and try to discover how we can fulfill it. Let's go with some questions. Who was first?